Welcome to our comprehensive course on DevOps. This course will guide you through the transformative journey that bridges the gap between development and operations in modern software engineering. DevOps has revolutionized how organizations build, deploy, and maintain software systems, and understanding its principles and practices is crucial for anyone working in technology today. Throughout this course, you'll learn not just the theoretical foundations, but also practical, hands-on skills that you can immediately apply in your work. We'll explore various tools, methodologies, and best practices that make up the DevOps ecosystem. Whether you're a developer looking to understand operations better or an operations professional wanting to embrace modern development practices, this course will provide you with valuable insights and skills. Before we begin our journey, it's important to note that DevOps is more than just a set of tools or practices. It's a cultural shift that has transformed how technology organizations operate. The principles covered in this course will help you contribute to this transformation in your own organization. Let's begin with an introduction to your instructor. Understanding the instructor's background and experience will help provide context for the real-world examples and insights discussed throughout this course. This combination of academic and industry experience helps bridge theoretical concepts with practical applications in DevOps implementation. Your instructor for this course is Dr. Mir Mohammed Asadullah, who brings both academic and industry experience to guide your DevOps journey. With over 30 years in information technology, Dr. Asadullah has witnessed and participated in the evolution of software development practices, from traditional methodologies to modern DevOps approaches. The academic background includes degrees from prestigious institutions, including a PhD in computational sciences and informatics from George Mason University and a Doctor of Business Administration from the University of Maryland Global Campus. This combination of technical and business education enables the presentation of DevOps not just as a technical framework, but as a business enabler that drives organizational success. Professional experience includes roles as Director of Cloud Computing at MetroStar Systems and Technology Architecture Consulting Manager at Accenture Federal Services. These positions provided direct insight into implementing DevOps practices at scale and understanding the challenges and opportunities they present. Since 2014, Dr. Asadullah has taught at the University of Maryland Global Campus, helping numerous students understand complex technical concepts and apply them in real-world scenarios. Notable achievements include teaching a MOOC course on software testing management that reached over 4,500 students globally through edX.org. Now that you know about me, I'd like to learn about you. Building a collaborative learning environment starts with understanding each participant's background, goals, and challenges. Let's take some time to introduce ourselves and begin forming our learning community. Let's take a moment to introduce ourselves and begin building our learning community. This isn't just a formality. Understanding each other's backgrounds, challenges, and goals will help us create a more engaging and relevant learning experience for everyone. When you introduce yourself in the discussion forum, please share more than just your name. Tell us about your current role, your experience with development or operations, and most importantly, what challenges you're facing that brought you to this course. Are you struggling with deployment automation? Looking to improve collaboration between teams? Or perhaps trying to implement continuous integration in a complex environment? Share a fun fact about yourself too. It helps break the ice and makes our virtual classroom more personal and engaging. Also, think about how you plan to apply what you learn here. Having a clear goal in mind will help you stay focused and get the most value from this course. Let me outline the structure and objectives of this course. Understanding the curriculum design will help you set expectations and prepare for the learning journey ahead. We'll cover both theoretical foundations and practical applications of DevOps principles. Our DevOps course is carefully structured to provide you with a comprehensive learning experience over 6 weeks. We've designed this course to be delivered in a classroom setting, combining lectures with hands-on labs and practical homework assignments. This blended approach ensures you not only understand the concepts, but can apply them effectively in real-world scenarios. The prerequisite for this course is basic Unix system administration knowledge. This foundation is crucial, as many DevOps tools and practices rely on command-line interfaces and Unix-like environments. If you need to brush up on these skills, I recommend reviewing basic Unix commands and concepts before we dive into more advanced topics. The labs are designed to give you hands-on experience with the tools and practices we discuss in lectures. These aren't just academic exercises, they're based on real-world scenarios you're likely to encounter in your professional work. The homework assignments will build upon what you learn in class, giving you opportunities to experiment and solve problems independently. This reinforcement is crucial for developing the problem-solving skills essential in DevOps practices. Let's explore what you'll achieve through this course. We'll cover a comprehensive set of concepts and tools that form the foundation of modern DevOps practices. Understanding these learning outcomes will help you track your progress and ensure you're getting the most value from the course. By the end of this course, you'll have gained practical experience with a robust set of DevOps concepts and tools that are essential in modern software development and operations environments. Let me walk you through what you'll learn and why each component is crucial. First, we'll dive deep into quality assurance practices. This isn't just about testing, it's about building quality into every step of your development process. You'll learn how to implement automated testing strategies and create quality gates that ensure reliable software delivery. Continuous integration and continuous deployment, or CI/CD, forms a cornerstone of DevOps practices. You'll learn how to set up automated pipelines that take code from commit to production, ensuring consistent and reliable deployments. We'll work with industry-standard tools to implement these pipelines in practical scenarios. Logging, monitoring, and alerting are crucial for maintaining healthy systems. You'll learn how to implement comprehensive monitoring solutions that provide visibility into your applications and infrastructure. This includes setting up meaningful alerts that help you proactively address issues before they impact users. We'll explore behavior-driven development and test-driven development, two methodologies that help teams build more reliable software. You'll learn how these approaches can improve collaboration between developers, testers, and business stakeholders. Service mesh architecture is becoming increasingly important in modern microservices environments. You'll understand how service meshes help manage service-to-service communication, implement security policies, and provide observability in complex distributed systems. On the tools front, you'll gain hands-on experience with GitLab for source control and CI/CD pipelines, Ansible for automation and configuration management, Docker for containerization, Jenkins for build automation and continuous integration, Kubernetes for container orchestration, Consul for service discovery and configuration. These tools were chosen because they represent the current state of the art in DevOps practices and are widely used in enterprise environments. The skills you learn with these tools will be directly applicable in most modern technology organizations. Now let's explore the fundamental concept of DevOps itself. Understanding what DevOps means and how it bridges the traditional gap between development and operations teams is crucial for appreciating the transformative power of these practices. DevOps represents a fundamental shift in how we approach software development and operations. At its core, DevOps is a set of practices that combine software development and IT operations to streamline and automate the software delivery process. However, it's important to understand that DevOps is more than just a methodology, it's a cultural and professional movement that has transformed the technology industry. The definition we see on this slide is intentionally broad because DevOps encompasses many aspects of software delivery. When we say it combines development and operations, we're talking about breaking down traditional silos that have historically separated these functions. This separation often led to conflicts, delays, and reliability issues in software delivery. Think of DevOps as a bridge that connects not just teams, but also processes and tools. It creates a continuous feedback loop that enables organizations to deliver software faster, more reliably, and with better quality. The automation aspect is crucial. By automating repetitive tasks and standardizing processes, we reduce human error and free up teams to focus on innovation and improvement. In practice, this means developers become more operations aware, considering aspects like maintainability and monitoring from the start. Similarly, operations teams become more deeply involved in the development process, providing input on infrastructure requirements and operational constraints early in the development cycle. As we progress through this course, you'll see how this definition manifests in specific practices, tools, and cultural changes that organizations need to embrace for successful DevOps implementation. The evolution of DevOps is a fascinating journey that reflects the broader transformation of the software industry. Understanding this history helps us appreciate why DevOps practices are so crucial today and how they've evolved to address real-world challenges. The story begins in the early 2000s with the rise of Agile methodologies. While Agile dramatically improved software development processes, it initially focused primarily on development teams, leaving a gap in addressing operational concerns. Organizations found that while they could develop software more quickly, they still struggled with deployment and operations. The concept of continuous integration emerged in the mid-2000s as a response to the challenges of integrating code changes across large development teams. Tools like Cruise Control and Hudson, which later became Jenkins, revolutionized how teams approached code integration and testing. These tools automated the process of building and testing code whenever changes were committed, catching integration issues early in the development cycle. The concept of web-scale operations emerged during this period, largely driven by companies like Amazon and Flickr. These organizations were facing unprecedented challenges in deploying and managing large-scale web applications. They needed to find ways to deploy code changes hundreds or even thousands of times per day, while maintaining system stability. Their solutions to these challenges would later influence many DevOps practices we use today. Amazon's transformation is particularly noteworthy. Their move to a service-oriented architecture and the development of what would later become AWS was driven by the need to scale both their development and operations capabilities. This approach demonstrated that treating infrastructure as code and automating operations tasks could lead to more reliable and scalable systems. Flickr's 10+ deploys per day presentation at the 2009 Velocity Conference was another pivotal moment. It showed the industry that frequent, reliable deployments were possible with the right practices and tools in place. This challenged the traditional notion that stability required slowing down the pace of change. The term DevOps itself has an interesting origin story. In 2009, Patrick Debois organized the first DevOps Days conference in Ghent, Belgium. This event marked a turning point in formalizing the DevOps movement and providing a platform for practitioners to share their experiences and best practices. The conference came about as a response to Debois' own frustrations with the traditional divide between development and operations teams. He had experienced firsthand the inefficiencies and conflicts that arose from this separation. The conference name, DevOps Days, gave us the term DevOps, which quickly became the banner under which various related practices and ideas would unite. As DevOps gained momentum, the focus on collaboration and automation became increasingly central to its identity. Tools and practices evolved rapidly, with new solutions emerging to address specific challenges in the software delivery pipeline. This period saw the rise of configuration management tools like Puppet and Chef, containerization with Docker, and cloud platforms that made infrastructure automation more accessible. The transformation of DevOps into a cultural movement is particularly significant. It went beyond technical practices to address the human aspects of software delivery. Organizations began to recognize that tools alone weren't enough. They needed to change how teams worked together and shared responsibility for the entire software lifecycle. This cultural aspect of DevOps emphasizes values like transparency, communication, and shared responsibility. It promotes a mindset where everyone involved in software delivery, from developers to operations staff to security teams, works together toward common goals. This collaborative approach has proven essential for organizations looking to achieve the full benefits of DevOps practices. Today, DevOps continues to evolve, incorporating new technologies and practices while staying true to its core principles of collaboration, automation, and continuous improvement. The lessons learned during its history remain relevant as organizations face new challenges in software delivery and operations. DevOps culture represents a fundamental shift in how technology organizations operate. It's crucial to understand that while tools and processes are important, the cultural aspects of DevOps often determine the success or failure of implementation efforts. Let's explore each key aspect of DevOps culture in detail. First, collaboration and trust form the foundation. This goes beyond simple teamwork. It's about breaking down traditional silos and creating an environment where development and operations teams share responsibility for the entire software lifecycle. Trust is built when teams are transparent about their challenges and successes, and when they work together to solve problems rather than assign blame. Continuous learning is another cornerstone of DevOps culture. In the rapidly evolving technology landscape, teams must stay current with new tools and practices. But continuous learning isn't just about technical skills. It's about learning from failures, experimenting with new approaches, and sharing knowledge across the organization. This includes conducting blameless postmortems after incidents and maintaining documentation that helps teams learn from each other's experiences. Accountability in DevOps culture differs from traditional models. Rather than individual accountability for specific components, we see shared accountability for the entire software delivery process. This means that when issues arise, teams focus on finding solutions rather than pointing fingers. It also means celebrating successes as a team rather than as individuals. The concept of shared ownership is particularly transformative. In traditional environments, developers might say, "I wrote the code, but operations broke it," while operations might say, "The code was flawed from the start." In a DevOps culture, both teams share ownership of the entire process, from initial development through deployment and ongoing operations. This shared ownership encourages better communication, more thorough testing, and more reliable deployments. The key principles of DevOps form a framework that guides implementation and helps organizations maintain focus on what matters most. These principles aren't just theoretical concepts. They're practical guidelines that drive successful DevOps transformations. Collaboration between development and operations teams is foundational to DevOps success. This means breaking down traditional silos and creating an environment where teams work together throughout the entire software lifecycle. Effective collaboration requires not just the right tools and processes, but also a cultural shift that encourages open communication and shared responsibility. Automation is a critical enabler of DevOps practices. By automating repetitive tasks, we reduce human error, increase consistency, and free up teams to focus on higher value activities. This includes automating build processes, testing, deployment, and infrastructure management. However, automation should be approached strategically. Not everything needs to be automated, and we must consider the return on investment for each automation initiative. Continuous integration and delivery represents a fundamental shift in how we deliver software. Continuous integration ensures that code changes are frequently integrated into a shared repository and automatically tested. This helps catch integration issues early and maintains code quality. Continuous delivery extends this by automating the deployment process, making it possible to release software reliably at any time. Monitoring and feedback complete the DevOps loop. This involves collecting meaningful metrics about both technical performance and business outcomes. Effective monitoring helps teams identify issues before they impact users and provides insights for continuous improvement. The feedback loop ensures that lessons learned from operations inform future development decisions. This automation diagram illustrates the continuous flow of activities in a DevOps environment. Let's examine each component and understand how they work together to create a seamless delivery pipeline. The process begins with planning and coding in development environments. Here, developers use version control systems to manage code changes and collaborate effectively. This leads into the build phase, where code is compiled and packaged into deployable artifacts. Testing is integrated throughout the pipeline, with different types of tests running at various stages. This includes unit tests, integration tests, and automated acceptance tests. The automation of these tests ensures consistent quality checks without manual intervention. Deployment automation enables reliable and repeatable releases. This includes infrastructure provisioning, configuration management, and application deployment. Tools like Ansible, Terraform, and Kubernetes play crucial roles in this automation. Monitoring and logging are continuous activities that provide insights into system behavior and performance. This information feeds back into the planning phase, creating a continuous improvement loop. The diagram emphasizes how these components are interconnected. A change in one area can trigger automated processes across the entire pipeline, ensuring consistency and reliability in software delivery. This communication diagram illustrates the complex interactions between different teams and components in a DevOps environment. Understanding these communication patterns is crucial for successful DevOps implementation. The diagram shows how development teams, operations teams, and various tools interact throughout the software delivery lifecycle. Traditional barriers between teams are replaced with continuous communication channels and shared responsibilities. Notice how information flows in multiple directions. Developers receive operational feedback about their application's performance in production. Operations teams have input into application, design, and architecture decisions. Security considerations are integrated throughout the process rather than being treated as an afterthought. Tools and automation facilitate this communication, but they don't replace human interaction. The most successful DevOps implementations maintain a balance between automated communication through tools and meaningful human collaboration through regular meetings, shared planning sessions, and joint problem-solving activities. This emphasis on communication helps prevent the common pitfall of teams working in isolation. When everyone has visibility into the entire delivery pipeline, they can make better decisions that consider the full impact of their choices. The benefits of DevOps extend far beyond technical improvements, delivering significant business value across multiple dimensions. Let's explore each major benefit and understand its impact on organizational success. Faster time to market is often the most immediately visible benefit. By automating deployment processes and removing communication barriers, organizations can deliver new features and fixes much more quickly. This improved velocity isn't just about speed, it's about reliably delivering value to customers faster than competitors. Improved collaboration represents a fundamental shift in how teams work together. When development and operations teams share common goals and tools, they naturally work more effectively together. This collaboration extends beyond just these teams. It often includes security, quality assurance, and business stakeholders. The result is better communication, fewer misunderstandings, and more efficient problem solving. Higher quality software is achieved through automated testing, consistent deployment processes, and early detection of issues. When quality checks are automated and integrated into the delivery pipeline, problems are caught and fixed earlier in the development cycle. This proactive approach to quality results in more reliable software and higher customer satisfaction. Increased efficiency comes from automating routine tasks and standardizing processes. Teams spend less time on repetitive work and more time on innovation and improvement. This efficiency gain often leads to reduced costs and better resource utilization. Moreover, standardized processes reduce the likelihood of errors and make it easier to onboard new team members. A successful DevOps implementation relies on a carefully selected toolkit that supports various aspects of the software delivery lifecycle. Let's explore these essential tools and understand their roles in enabling DevOps practices. Source code repository tools like Git, CloudForce, and Subversion provide the foundation for version control and collaboration. Git, in particular, has become the de facto standard due to its distributed nature and robust branching capabilities. These tools enable teams to track changes, manage multiple versions, and collaborate effectively on code development. Continuous integration tools such as Jenkins, GitLab, CI/CD, and CircleCI automate the build and initial testing processes. These tools automatically compile code, run tests, and provide immediate feedback to developers. Jenkins, for example, offers extensive plugin support that allows it to integrate with virtually any development tool or platform. Configuration management tools like Ansible, Chef, and Puppet automate infrastructure, configuration, and management. Ansible, with its agentless architecture and YAML-based playbooks, has gained popularity for its simplicity and efficiency. These tools ensure consistent environment configurations and help prevent the "it works on my machine" problem. Containerization and orchestration tools, primarily Docker and Kubernetes, have revolutionized application deployment and scaling. Docker provides container virtualization for consistent application packaging, while Kubernetes manages container orchestration at scale. Together, they enable efficient resource utilization and simplified application deployment. Monitoring and logging tools, such as Prometheus, Grafana, and the Elk Stack, provide crucial visibility into application and infrastructure performance. These tools help teams identify issues quickly and make data-driven decisions about system improvements. Collaboration tools like Jira, Slack, and Confluence facilitate communication and documentation. They help teams track work, share knowledge, and maintain clear communication channels across the organization. Build servers like SonarQube, Jenkins, and Artifactory manage the build process and ensure code quality. SonarQube, for instance, provides detailed code analysis and quality metrics that help maintain high coding standards. Test automation tools such as Selenium and Water enable comprehensive application testing. These tools support various testing types, from unit tests to end-to-end integration tests, ensuring consistent quality across releases. Virtual infrastructure providers like AWS, Microsoft Azure, and VMware Cloud provide the flexible, scalable infrastructure needed for modern applications. These platforms offer APIs and services that support automation and scaling, making them ideal for DevOps practices. Implementing DevOps requires a structured approach that considers both technical and organizational aspects. Let's explore each phase of the implementation process and understand how to execute it successfully. The first step is to assess current state. This involves a comprehensive evaluation of your existing processes, tools, and culture. You'll need to understand your current software delivery lifecycle, identify bottlenecks, and measure key metrics like deployment frequency, lead time for changes, and mean time to recovery. This assessment should involve stakeholders from all relevant teams to ensure a complete perspective. When evaluating your current state, look for specific pain points. Are deployments manual and error-prone? Do teams operate in silos? Is there a lack of automated testing? Understanding these challenges helps prioritize improvements. During my time at Accenture, I observed that organizations often discover that their perceived problems aren't always their most critical issues. The plan and prioritize phase is crucial for success. Based on your assessment, create a roadmap that outlines specific improvements and their expected impact. Prioritize initiatives that offer the highest value with the lowest disruption. This might mean starting with version control improvements before tackling complex deployment automation. Your implementation plan should include clear milestones, success criteria, and metrics for measuring progress. It's essential to align these with business objectives. The reference document from the Software Engineering Institute provides excellent guidance on creating such roadmaps, especially for organizations in regulated environments. The implement and automate phase is where the actual transformation begins. This involves introducing new tools, establishing automated pipelines, and implementing improved processes. Start with small, achievable wins to build momentum and demonstrate value. For example, begin with automating a single application's deployment before expanding to your entire portfolio. Finally, the measure and improve phase establishes a continuous improvement cycle. Monitor your key metrics, gather feedback from teams, and continuously refine your approach. This isn't just about technical metrics. Consider team satisfaction, customer feedback, and business outcomes as well. Implementing DevOps comes with significant challenges that organizations must address proactively. Understanding these challenges helps teams prepare for and overcome them effectively. Resistance to change often presents the first major hurdle. This resistance can come from various sources: developers comfortable with existing practices, operations teams concerned about maintaining stability, or managers worried about short-term productivity impacts. To address resistance, focus on demonstrating early wins and involving team members in the transformation process. Share success stories from similar organizations and provide clear evidence of how DevOps practices will improve daily work life. Regular communication and transparent decision-making help build trust and buy-in. The cultural shift required for DevOps success cannot be understated. Moving from siloed teams to collaborative practices requires significant behavioral changes. This includes learning to share responsibility, embracing automation, and adopting a continuous improvement mindset. Success requires strong leadership support and consistent reinforcement of new cultural values. Tooling and infrastructure decisions present technical challenges. Organizations must select, implement, and integrate various tools while ensuring they work together effectively. This often involves balancing modern tools with legacy systems and considering security requirements. Make these decisions carefully, considering your team's capabilities and your organization's specific needs. Skill set gaps commonly emerge during DevOps transformations. Teams need to learn new tools, adopt new practices, and often step outside their traditional roles. Create comprehensive training plans that address both technical and soft skills. Consider bringing in experienced practitioners to mentor teams and accelerate learning. As we conclude our introduction to DevOps, let's review the key concepts that will form the foundation for our deeper exploration in the coming weeks. First and foremost, understand that DevOps is not just a set of tools or processes. It's a comprehensive approach that combines software development and IT operations. This combination is crucial for modern software delivery, enabling organizations to move faster while maintaining reliability and quality. The core practices we've discussed, collaboration, automation, continuous integration and delivery, and monitoring, work together as an integrated system. Each element supports the others, creating a feedback loop that drives continuous improvement. Some of the most successful implementations may be those that maintain balance across all these elements, rather than focusing too heavily on any single aspect. The benefits we've explored, faster time to market, improved collaboration, higher software quality, and increased efficiency, directly impact business outcomes. These aren't just technical improvements, they translate into competitive advantages in today's fast-paced market. The history of DevOps provides important context for understanding why these practices evolved and how they address real-world challenges. From the early days of Agile to the emergence of web-scale operations, each phase of DevOps evolution has contributed valuable lessons that inform current best practices. The role of Patrick Dubois in formalizing and popularizing DevOps highlights how the movement grew from practical needs rather than theoretical concepts. This grassroots evolution continues today as organizations adapt DevOps practices to their specific contexts. Understanding that DevOps is a cultural movement is crucial for successful implementation. While tools and processes are important, the cultural aspects, collaboration, shared responsibility, and continuous learning often determine the ultimate success or failure of DevOps initiatives. The implementation process we've discussed provides a framework for your own DevOps journey. Remember that this is not a one-time transformation, but an ongoing evolution. Each organization's path will be unique, influenced by its specific challenges, culture, and objectives. We've explored various challenges you might face, from resistance to change to technical hurdles. Being prepared for these challenges and having strategies to address them will be crucial for your success. Throughout this course, we'll delve deeper into specific approaches for overcoming these obstacles. The numerous case studies and real-world examples we'll examine in coming weeks will demonstrate how organizations have successfully implemented DevOps practices. These practical examples will help you understand how to apply these concepts in your own environment. We've covered a lot of ground in this introduction to DevOps. Now is the perfect time for questions and discussion. Throughout this course, I encourage you to ask questions, share your experiences, and engage with your fellow students. Your diverse perspectives and experiences will enrich our learning journey together. Whether you have questions about specific concepts we've covered, tools we've mentioned, or challenges you're facing in your own organization, don't hesitate to ask.